Alright, a number of you have asked to have a little bit more information on understanding a mortgage loan. That is, how to set up an amortization table and understanding really where your money is going in terms of principal and interest. In this example, we're going to use 5 different functions. We're going to use the payment function, the PMT. We're going to use PPMT, which identifies the portion of the payment that's going towards principal and the amount that goes towards interest. We're also then going to look at the functions cumulative principal and cumulative interest payment. The cumulative principal shows us how much we've paid towards principal, and the cumulative interest is how much has gone towards interest. We're going to have 2 scenarios, a 15-year and a 30-year mortgage. When it comes to a 30-year mortgage, I'm going to copy and paste over some values just so we can move a little faster. So we start off with the payment function, and we identify the rate on the 15-year mortgage. We want to hit F4 to lock in this reference since we're going to drag cells. And we're going to divide by 12 since we account for months within a mortgage. The number of periods is 180, that's 15 times 12. The present value is how much we're spending at time 0. So if we assume we put 20% down on a $250,000 house, we have a loan amount of $200,000. The future value we're going to pay down to a value 0, and the type is 0 at the end. So we can see that our monthly payment for a $200,000 mortgage, 15-year mortgage, with a rate of 3.5% would be $1,429.77. What we next want to figure out is how much goes towards principal and how much goes towards interest. So we'll type in equal sign IPMT. Again, we'll identify the rate. F4 divide by 12. The number of periods is 180. The number of period, mistake. We're first going to reference the period that we're in. So what we're doing is we're telling Excel here for payment 1 how much is going towards interest. Because as we can make more and more payments, our principal value declines. Then what that tells us is our overall balance in terms of which interest accrued against, that is the principal, also declines. So the amount that goes towards interest every payment is going to decline, and the amount that goes towards principal is going to increase slightly every payment. We know there's a total of 180 payments, periods. The present value, again, is the cash outflow at time 0. Future value will be 0, and the type 0. We will find for the principal. Now you could technically subtract the interest from the payment and get the principal amount, but we're going to do it directly to make sure that we have the correct amount. So we're just entering for all the values of this argument. Now you may have noticed I'm typing 0 in for type on each of these, where technically it doesn't have to be entered. The reason being is once we get to the cumulative principal and cumulative interest, if we don't type in a 0 for type, the function doesn't work correctly. So we can sum these quickly just to make sure that our functions are being employed correctly. And we see that it adds up, so we know that our functions are correct. We'll next use the cumulative principal. Reference the rate. Number of periods is 180. The present value. In this scenario, we don't actually enter it as a negative. If we enter it as a negative, the cumulative principal function just doesn't work, so we have to enter the positive amount. The start value is period 1, so we're going to hit F4, and what we're going to do is calculate the cumulative principal since we started paying the mortgage, and what this is going to do is going to give us an inverse relationship to the loan amount. So as the cumulative principal goes up, the loan amount is decreasing. And the end period is the period reference. And so if we just put a close bracket here and we hit enter, we'll see that this doesn't work. So we need to type a 0 value. And all of a sudden it works. We can just copy this over to cumulative IPMT. Our rate's locked in. We have 180. We're going to lock our present value in. You see our start periods are the same. Change that to C4. And we're good. As a quick note, we need to lock in C8 there. Okay. So pretty much we're seeing how much goes towards our what our payment is, how much goes towards interest, how much goes towards principal, what the cumulative amount is. And what we're going to then do is just copy these over to the 30 year. And so where this goes wrong is we need to change H12 to O in each of these examples. And we need to change 180 to 360. So just a moment while we get this all carried over. One last error I noticed in these functions, we didn't lock in the loan amount. Alright. Those all look correct. You see that our value is equivalent here. Change that to O. There we go. So what we can do now is drag these values down. And we've made some type of error here. Leads me to believe we enter 360, 80, 60. Alright, try that one more time. Nope, looks like there's still an error. Okay. The reason why I say there's an error, we have an interest and a principal that are obviously greater than our payment. That looks better. What we can see is the sum. These two values, and they should add up to our payment, which it does. Perfect. That looks correct. These values match these. Alright, let's try that one more time. So what we're seeing here is over the life of the loan, how much goes towards principal and how much goes towards interest. And so why this is interesting is we can see that after 2 years, we paid $21,000 towards principal and $13,000 towards interest, and we can compare the same to our 30-year mortgage and see a slightly different result. We've only paid $6,700 towards principal, and we've paid $17,000 towards interest. So quite scary. So of the two, you beat the judge in terms of which mortgage you